Okay, we're live. Hi everyone, it's Brian from It's VRK, and I have um, some interesting stuff today. So one of the things that I've been wanting to do for a while is start on an effort to standardize motion telemetry for simulators. Over the Easter holidays, I sat down and spent some time sort of mapping out a draft standard for that and sent some emails out and tried to get the word out to as many people as possible that I could within a short time frame. And so from that, I've had some good feedback from multiple people. And I have today with me David Tucker from iRacing, and he's going to walk through some of the iRacing APIs around that. But so where I'm at the moment is step one, I defined a schema for the standard, and now I'm seeking input from developers of games and motion software, and also hopefully people who have created plugins for motion software. And then I want to iterate and refine that standard. Some of the feedback already has been that it should encapsulate telemetry greater than just the motion data. So sort of trying to figure out how that would work potentially. And, one of the telemetry requirements are different for every type of game in given genres at least. So that's going to take a little while to unfurl. But once we have that standard sort of ratified, hoping to find developers who will be willing to help create plugins for game engines so that game developers can just use that plugin and connect all the data points, and it will output in the defined standard. And then also development of plugins for the motion software, and then spread the word as wide as possible. So if you can please, David, can you please introduce yourself and tell us a little bit about what you do at iRacing, and then jump into what we're planning to go over, please?
Sure. So I'm David Tucker. I'm a software developer at iRacing.com. We make a sim racing PC game. I've been here 15 years. We've been public for about 15 years. The company, I think, is getting close to 20 years old. In that time, most of what I've done is worked on uh, 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 tools facing the client, the client. So things like keyboards, force feedback wheels, joysticks, APIs that are used by motion platforms. I mean anything that you touch in the game, I pretty much probably wrote the code for it. Yeah. When you reached out, I thought this was an interesting idea, and definitely something I'd like to see more of. Is that um, there hasn't been much work, or at least not much successful work, um, in the PC gaming market or console market for that matter, on standardizing these sorts of APIs. So like the APIs that we're using for wheels is direct input, and I think the last update to it was probably 20 years ago. Wheels have gotten better, but the APIs for talking to them haven't. As far as I know, there's no real standard way to get any of that data off of a console. And then obviously on the PC side, it's kind of a hodgepodge. Some games support telemetry outputs and some don't. Sometimes motion platform developers have to hack games just to be able to pull the data out.
One of the things that is actually forefront in what I was trying to do was to really target so that consoles can work with motion simulators. So basically, the idea is that the effort by a developer would be the same for both console and game. And so basically that leans towards some form of UDP or WebSockets or something, so that
Right.
because generally the motion hardware is running via software on a PC somewhere on your network, so that software needs to be able to inspect that streaming telemetry data from the console, which you can't really
Yeah.
do with a memory map file. So, yep.
Yeah, no, that's a good point. And definitely, yeah, the memory map files won't work in that case. Um, yeah, consoles are a particularly sticky problem. I've noticed over the years that the peripherals that the wheel makers have come up with struggle on the console side. Like
Hmm.
they might have a real nice display, but only one or two games use the display.
Mm.
And I think a big part of it is, I mean, partly is because, once a console game's done, it's done. Nobody's going to go back and retrofit a new wheel.
Mm.
But a lot of it is too that the consoles are just highly limited. Um, so anything that breaks that open a little bit more so that you can get more data out of games to drive motion, to drive better force feedback, to drive all these other peripherals, displays and LED lights and whatever. Those are all good things.
Hmm.
There's a lot of great hardware on the PC side that the consoles just don't see, um, and it's a shame.
Yeah.
So, with that said, we're PC, so we're happy for that. We're happy for all the cool hardware on
Mm.
our end, and yeah, um, yeah. So I take it you're interested in an API for getting data out of the games and not so much in the games driving the motion directly, right? You're
Well,
not trying to.
I mean, it's to do motion is typically we're just reading data, so that's less of an issue there. A few people have responded about writing data back in, and I can see places where that would make sense. But I feel that there would be a concern from game developers that that would potentially lead to people using it in ways that give unfair advantages.
Right.
So one of the ideas at the moment is perhaps on given telemetry data points, we could allow writing. If we go with a WebSockets, for instance, WebSockets would actually support writing data back.
Right.
So like it's not out of the scope of possibility, but I think we have to navigate that quite carefully so that it doesn't allow effectively cheating in the game. And you know, in ways where there's a limited set of the telemetry that's writable based on what the developer wants to allow.
Yeah, no, and that's a good point. I mean, it's a big concern of ours, and it's growing all the time.
Mm.
And that closing the loop between telemetry output from the game and feedback through the control inputs uh, or any inputs,
Mm.
um, it opens up a whole can of worms for cheating.
Yeah.
So we solve that generally by holding back a few key pieces of data. Like we don't output your position. So
Mm-hmm.
you can get orientation and acceleration and velocity, but no position. That way you
Mm.
don't know where you are on track when you're
Yeah.
racing.
In my
And there,
initial draft that I put up onto GitHub, I had keys for opponents, and I took all of that out because if you don't know where the opponents are, you can't automatically fire at them or something like that, for instance, if it's a shooting
y-
game. But yeah.
yeah, exactly.
Mm.
And then the other one we hold back on is any info on your tires. So tire
Mhm.
temps, tire wear, tire pressure, all of those are easy to convert into something that modulates your brakes or otherwise, helps you because you already know if your car's an oversteer or understeer through
Mm.
through
The
the motion
physics.
platform
Yeah.
data.
Yeah.
So you're trying to hold back just enough that they're not able to really effectively close the loop. And
Mm.
even there, there's enough information already just for motion platforms to allow force feedback wheels to steer into a slide. Um, so it's a problem,
Mm. Mm.
and it's going to grow. I mean, the next step is, um, cameras are just getting better and better.
Yeah,
With
just
more and more
AI
smarts on them.
inference sort of stuff.
Yeah,
Yeah. Yeah.
yeah, the AI kind of stuff where you can just point a camera at the screen and it can find the position of everything for
Mm.
you. Um, Fortunately, right now that's a little beyond the average player's abilities,
Mhm.
and there's not enough incentive for cheaters. But I think in 10 years that'll be a big headache.
Yeah.
So yeah, so yeah, we've been doing telemetry forever. I got hired on, like I said, 15 years ago, and one of the first jobs that I was given was to improve our telemetry. So
Mhm.
our original telemetry was a struct that we pushed out, and it probably had 30 entries in it. but we were never able to change that struct. It was
Mm.
static because if we changed it, then, whatever clients were using it had to be recompiled to handle
Yeah.
a slightly larger struct.
Hmm.
And then the way we had it set up, we had a bidirectional memory map file where only one person could latch onto that uh, file um, and talk to the sim. So we could support a motion platform, but not a display
Mm.
at the same
Hmm.
time. So, it was kind of it was a good effort for what it had been, but it was really holding back the peripheral development.
Mm.
So I came in and I'd done work at the for the government at the U.S. Geological Survey doing telemetry collection,
Hmm.
among other things. And so I'd had experience with these little data loggers that you stick out in the field, and they basically, um, you have a bunch of inputs into a box. You 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 just have a giant array that you mark locations um, in a data line and just say, bits 2 through 12 are going to get, data from this input and whatever. And then just every, on a clock, it just ticks out
Hmm.
data lines and dumps it to a log file. And so I was like, well, okay, this is kind of the same idea. So I very quickly came up with our current system, which is very dynamic. So we have a one-way push to the client um, that we push out at a very fixed rate. Um, and then that way, as many clients as want to can listen. And we don't need to have, because there's no bidirectional communication, we don't need to have a port open
Hmm.
for them to talk back to us. Um, and like I said before in an email, we have a header that's built into the data format so that at startup, we find all the variables that we could possibly log out, and then we put them into a header, and then as soon as we're ready, we mark the header as finalized and then push it out to the clients.
Hmm.
And that header contains the names of the variables, their a text string that's readable, so that clients can figure out what's there without having to know how to parse some binary blob. And then the data types, if it's an array, the array size, um, and the units, yeah, and then an offset into the actual data structure. And that way, it's all self-documenting, so that um, on our end, the developers are able with just a line or two of code to add a new variable to log out.
Hmm.
So they just create a new data type and stuff a value into it. It gets logged automatically into telemetry, and they don't have to think about it. And then on the client side, new variables show up. Nobody has to recompile. You know, they're able to look up offsets into our database based on variable names. So they
Hmm.
can do a string lookup on a variable and then find the data. And then the last step is that once, so in our case, at 60 times a second, we output a big binary blob uh, of data, and then the header tells you where in that binary blob the actual data lives.
Hmm.
We do that for efficiency. Well, we're kind of a C-oriented group, and we don't have to deal with UDP or anything. So
Yeah.
binary binary blobs work great. But it's really opened up things. I think when I started, I was logging maybe 200 variables, and now we're in a debug build. We're probably getting close to 20,000 variables.
Okay.
So it's super efficient. We're able to dump just a ton of data out, and yeah, the clients. The nice thing is that our API has hardly changed at all since the first month or two that I released it.
Hmm.
So we've got programs that are 15 years old and never been recompiled that are still working
Wow.
today
Yeah.
because, you know, because we set it up so that the interface doesn't change,
Mm.
but the underlying data can change.
Yeah.
So
Um, Sorry, I'm just gonna. I'm getting a message from YouTube that we're not getting enough data through, so I'm gonna pause the stream and change
sure.
the bitrate. Right, just clicked back on air, so hopefully it should restart. I just want to watch. Yep, cool. We're back on. Um,
Cool.
so what I wanted to say there is one of the key things that I was doing in the structure. So I was trying to think about, again, I was motion centric. So I was trying to think about potential future capabilities of motion simulators as well. And so one of the things I did was have this concept of, I can't remember what I named it now, but it was the the power points of power basically. So I called it drive points, and the idea is that any given vehicle might have a different number of drive points. So a car has 4, but what that means is that the data structure is like, to me, a standard shouldn't define necessarily the exact standard, but there'll be certain things that are required and then others that are optional, like the drive points would be an optional thing. And it should define how to define those in the correct way such that it can be inferred. Now, with what you said about tire pressures, for instance, perhaps drive points don't contain certain data, but I was thinking about if you're in a racing car and you go over the ripple strip, and you had butt kickers or something on individual sort of areas that correspond with the wheels, then the vibration could be just those ones, not the entire 4, for instance. So, or if if you had 2, it could be on the right side of your motion simulator that corresponds to where the wheel is on the ripple strip. Now, with what you said, it sounds like your binary structure could account for that in the headers, sort of telling you what's there. But in any given game, like in some games, it could be that different vehicles in the same game might have a different number of drive points, for instance. So, I'm coming from a web development backend, so I'm trying to think of it as an API that can sort of self-document to a degree. And I've kind of always heard, from one of the other developers, the developer of FlyPT, we had a 2-hour discussion last week where he sort of outlined some of the issues that he's found with UDP, and some of them these I hadn't even thought of, which is like with UDP, even in multicast, it doesn't really allow for multiple clients from the same IP address unless you have a different port for each of the clients. So that's something where I'm thinking web services or WebSockets or maybe MQTT, as it's more of a subscriber type of framework. So multiple things could subscribe to given data points, and then it just sends out the relevant data to those things. Do you have any thoughts about that?
Yeah, I mean, I'm not really a network programmer, but
Mm.
years ago I worked at a company doing advertising on TVs, and we did a UDP broadcast to get the data out to all of our TVs,
Mhm.
and we had just a heck of a time trying to get the data to pass around. Like a lot of routers will block it
Mm.
just flat out, or it obviously can't pass from one um, group to another. So if you're on a wireless network, but your computer's on a wired network, they may not be able to talk.
Mm.
So I would be thinking through those. I don't know what the state of the art is on getting data out of a console. Like
Mm.
what certainly worthwhile trying to figure out if anybody's successfully done anything and what they've tried. But I would be slightly concerned that um, you're going to have a lot of issues getting things to actually sync up properly.
Mm.
Um,
Well, WebSockets
it's
is already used for like telemetry in lots of things, including online games. So it should, it's designed to be performant and timely. MQTT is more for networks where there may be more latency. The differences between those two is WebSockets is a TCP, so it's
right.
acknowledges all of the packets, whereas MQTT is more like UDP. Packets can get dropped, and it doesn't really matter so much.
And that's where we ran into trouble is that TCP would be working fine and UDP would be falling to pieces. And
mm,
I think it's because it wasn't getting used nearly enough. And so a
yeah,
lot of it just wasn't getting tested on the hardware.
yeah. The other
So
thing is you can't really use UDP broadcast, which would get past the ports issue, but then it just floods your network. So
yeah.
yeah, so
Yeah. So I mean those are the things I would worry about. I mean and the other one to think about is like a lot of the console companies aren't really interested in you using the network
mm.
without paying them. So it may or may not be okay for you to talk straight to a computer. Uh,
Oh, you mean any network at all, like your
yeah,
local network, because it's not doesn't need to go outside of the
yeah.
user's local
So
network. But I guess they see it as a potential vector for attack as well. So
it's been a lot of years since we looked into it, but they were saying like if you had assets stored on a local server, like on the web,
mm,
you weren't allowed to pull them into the console. You had to go through their servers.
okay.
Uh,
The main difference
so
here, I mean, I guess maybe they'd say the same, but we're only pushing data. Well, at this stage, I think the safest is only pushing data out. Um,
yeah,
so, and that's another factor, like the console sort of limitations, maybe another factor that just means it's read only. That like it's just
yeah.
broadcasting data and that's it. Um,
And I don't know how you go about getting in touch with someone at Microsoft or Sony, but
if
um,
anyone watches and knows someone, please reach out and let me know because that is a problem already. Like I've
yeah,
sent tweets out and I don't have a big profile on X or anything, so it's like one small guy in Australia sending a tweet out to Asobo and like lots
yeah,
of developers and stuff don't get a reply. So
yeah. No, and
yeah,
that's a challenge.
I mean, hopefully I will have some contacts. So I am in touch with some of the motion rig developers who have contacts at various places. So, um, but I just need to get those details back yet. So
Yeah,
I also do have contacts with multiple developers of motion software. Um, so I think that gives that side we have some good coverage of. I have sent out contact emails about this effort to other motion rig developers. Um, the biggest one I think is game implementers and people who've created plugins for motion software already. But the biggest sort of hurdle I see is, I'm not a developer. Oh, I'm not a game developer as a background. I do development, but not in this area. And I definitely don't have the knowledge of all of the possible telemetry points for, say, a racing game versus a flight sim. And so
right.
we do really need to try and find people to be involved that have that knowledge so that we can put all of this next to each other and go, okay, what are the commonalities here? Or how could we potentially refactor this data so that it could be a commonality um, rather than have everything be a unique sort of telemetry point.
Yeah,
And then the other thing is we can have core telemetry and then have the concept of um, genre specific or game specific stuff that so the initial data packet points you off to the specific telemetry for in a flight sim all of your altitude, flight speed, all that sort of stuff, and in a racing, whatever the like lap times, and all that sort of thing. So definitely, if
yeah,
anyone can get those people in contact, there's a Discord that is linked in the show notes. So it's probably of most interest to those developer type people, but I'm more than happy for any end level consumers to jump in and have a look. Um, but yeah, that.
well,
Hmm?
I was going to say, and to that end, I would be focused on having I don't know what you want to call it, a template, maybe, so that a game could say, I support, the motion profile, I
Mm,
support the race sim profile, I support the, whatever, um, and there'd be a subset of data values that then says I guarantee I'm going to fill these in,
Yeah.
Um,
So that's part of what I hope to tackle by providing plugins for game engines. So one of the things we could do, like ideally, if we can define this in some form of schema that can be
right,
referenced, then the plugin, you could just drop down and pick the relevant schema, and then the plugin could inspect the schema and build the UX within Unreal or Unity or whatever with the values that need to be populated, and you just populate them.
right.
Um, hook them up where the data comes from in your game. Like, I think if we have a well enough defined schema, then that should be possible. At the moment, I've been looking, like we've had one developer, so the FlyPT developer is pushing for structs as the method to do it, but I think structs have that problem of that you've said already,
Yeah,
sort of, yeah. So um, I initially went with JSON because I thought something that's easy to read for end users and developers would be good, but it's overly verbose. Um, and although it is readable, it's not as readable as say TOML. Um, so I've sort of been playing around with refactoring it as TOML because TOML supports most of the things that I wanted to do in JSON, and there is also a validator of you can validate a TOML file against a JSON schema. So we could define the schema in JSON, but create the output in TOML. And it's as lightweight almost as a struct anyway. So the only thing is, what's the performance impact of processing that at the plugin, like the consumer plugin end, I guess. And it would support. I think I really think WebSockets is possibly the best approach, but I've still got some plans to try and seek input on that as well. So
yeah,
and the thing is, everyone worries about, like, the idea is that the plugin would implement the WebSocket service and everything, so it's not on the developer to re-implement that every time. Like, I think the overarching goal is to make it easier for game developers to do this thing,
right.
which means there's more games that have this, which means more people can use peripherals or motion simulators, and there's more games with that. So it should benefit everyone. It also means that the developers of motion software will have to do less work to implement a plugin for every single game because it'll be standardized. There'll probably be the ability to have a meta plugin where you just, it's this type of game, so I can use the meta plugin, then we feed it the game and what vehicle in the game, and as long as the unique values, and that would be defined as needs to be unique, then you could save a profile for every game and every vehicle within a game that's tweaked to what you want. So,
Yeah,
it should make life a lot easier for everyone. The other big benefit that was discussed with the FlyPT developer is that, as you know, indie game developers may not have all the resources to even find out and know what possible telemetry to send, but having a standard, they can just look at the standard and go, oh yeah, I can do this. I'm making a flight sim. Here's all the possible things. Here's the required things. Well, I can start with the required things, and then if the game takes off, I can add the non-required stuff later or something like that. So it should
yeah, no,
help developers a lot. I think that's the aim. So
yeah, no, that'd be a big help. So yeah, so I have a couple of points on that.
sure.
I would pick underlying technology that is easily ported to lots of languages.
Mm-hmm.
So whatever that is, I mean, it's everything you've talked about seems like it falls into that category. And I would define how you're communicating at a low level cleanly and publish that.
Yes.
And then,
Yeah.
like you said, have a reference API in a few languages. Probably the C++ and C# would be the obvious choices.
Mm-hmm.
Um, that's well developed and tested, and give that away as source code and precompiled
Mm-hmm.
libraries, whatever people are looking for.
Yeah.
But the key being that way it's easy for a producer that's not interested in the details to just grab the DLLs or whatever and
Mm.
run with it. But if they need to do something specialized, it's all right there. They can dig in, they can make it, they can port it over to their Go language or whatever,
Mhm.
and it's no biggie. Um, and then I would concentrate on having a whole suite of tests on the other end. And this is where I think most standards fall apart is they never give you a reference.
Well,
You
this
know,
is where if we have a schema, you could actually run the schema checker against the output to see that it validates. So,
well, that's good, but you want to go further. You want to have
mm,
something that's going to display the forces.
yep,
It's going to validate the force ranges. A big problem you're going to have is that every game's got a different. So like our game focused really hard on realistic.
mm,
So if you're pulling, you know, a G in a corner,
mm,
we're outputting a G. But if you're making a an unrealistic race car game, maybe you're driving around Mars, right?
mm,
What should the forces be? And then now, how's the motion platform going to adapt to it? If you're driving around on Saturn, you might be pulling 10 Gs in the corners, whereas if you're bouncing around the moon, you might be pulling a tenth of a G in the corners. Your motion platform can't just say, okay, I'm gonna play a 10G
mm.
effect. It's got to rescale everything to the fairly small range that the motion can handle.
Yeah,
You
initially I
know,
had like an array that was environment information. So it was basically the current environment that the vehicle, the physics object is in, where I did, and it was kind of a gut instinct thing of having, what is the gravity, what is the pressure, um,
right?
that sort of thing. But I, I haven't put it in my more refined versions of the spec. It's still in the README at the front, but it's one of those things that my gut instinct tells me that there's value in having that there, but I don't know what the motion simulator developers and uh, think about that, because we get to the point of, is it the game's job to do that, or is it the motion simulator's job? Does the plugin do that processing, that sort of stuff? I,
Yeah, and I think it's the motion software's job,
mm,
but it's the game developer's job to have rational values. You
yeah,
know what I'm
yeah,
saying? So you need to know, like, if you're sending out a transform, it needs to follow a convention.
mm,
Right hand rule, whatever. Um, you know, it all needs to be rational,
yeah,
and that's all too often I've playing around with these APIs. They get too complicated. People end up using a tiny section of it, and then a lot of it's just not ever hooked up right.
yeah,
So yeah, so having something sitting on the other end to be able to that anybody can fire up that's developing a game and have
mm,
it just parse the data and say, wait a minute, this doesn't look real. You're missing these three
it's a
variables.
good
This
idea.
one's out of specs.
Yeah, yeah,
I think that'd be a good step.
mhm.
So along those lines, you were talking before about tires or action, force
Drive
actuators. I don't.
points. Yep.
Yeah, um, that's a good point and not at the same time. So
Mm,
like, I just fundamental motion is um, something that every type of platform should be getting the exact same data.
yeah.
And you should be able to only have basically acceleration and rotational velocity
Mm,
and 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 recreate all the motion. Now, in reality, the platforms don't move very far. You kind of need to tease more out of the data than you could if you had some big military grade 6 degree freedom system.
yeah.
But um, in theory, you shouldn't need to know anything about whether it's a car or an airplane or any of that other than, like you said, having a name of the game, a name of the vehicle, and a
Mm,
name of the location so that they can look up a pre-tuned profile
yeah.
for that vehicle.
Mhm,
Um, but you're right in that there are effects that we would like to output with location.
mm,
So, like in our game, we do output a rumble strip per tire effect.
mhm,
But we just give it a name and we say it's the left front rumble strip or the right rear rumble strip or whatever. Um, and, obviously that's uh, probably a little too car centric.
Yeah.
But
That
you know,
was the only reason that I went to a drive point sort of
yeah,
array of objects. So you could add as many as you needed or as little as you needed, because like if you're in a mech, you've got 2 legs maybe or something like that. So it's
yeah,
but the
yeah,
real
exactly.
question there needs to go to the motion software developers. Are like, would you be able to actually do anything good with this, or are we just adding stuff there that doesn't give any value?
Yeah, and I think the answer is they probably could do something with that, but you probably get 90% of the way there if you just output a rumble strip
Mm,
value that didn't even have a corner associated with it,
yeah, yeah,
So, uh, so in my job, one of the projects I work on is we generate a low frequency effect that's there to drive base shakers. And so I made a whole system that does that. And in a lot of experiments that I've done, I found that um, it's not really that useful to have shakers put on all the corners and spread all over the vehicle.
mm,
80%, maybe 90% of what you could get out of it can be done with just one shaker.
mhm,
Um, and it's the same, with the other devices. Your mind is really good at filling in the details. If you
yeah,
play a sound in stereo that says the sound's coming from the right side and the shaker buzzes, your mind's just going to swear it came from the right side of the chassis.
mm, mhm,
Um, so uh, there's value in that to a limited extent, but I wouldn't put that as like a top tier priority.
mm,
Well, and like I said, what I would do is have very simple schemas, small ones, where everybody is expected to fully
yeah,
fill it out. So you might have a motion one schema and a motion two schema,
mhm,
and maybe even a motion three schema where the one schema has got, velocity, acceleration, rotational velocity, um, you know, and that's it. And then
mm,
the motion two schema might have, number of tires or location on the car, whether they're gonna hit on rumble strips or whatever, whatever other details you might have.
mm,
And then you might have an airplane schema that gives you flaps and ailerons and whatever, and engine RPM, and a car schema that gives you tire count and air,
mm,
whatever. But by making them really small, then it's almost guaranteed, and insisting that if you're going to do a race car game, you've got to implement schema one for
yeah,
whatever, um, then it's almost guaranteed that people on the other end are going to be able to use your schemas.
mm,
The problem is if you had, say, a car schema that had 100 things in it, right? Everybody might put one thing in there, but chances of
well, the thing is, you can run
everybody,
into where there's like values that have dependencies. If you don't supply the dependency, then you don't have enough
right?
data to make anything useful. So, yeah.
Yeah, and so and I would have small schemas where everything could be there, and because that's the only way it works is if everything gets filled in. So like
Mm,
if you look at the USB spec, they've got probably 100 different uh, device types that they support, and they get super detailed.
mm,
Like you can make a device that's a weights and measurement device that has all kinds of information on it. The problem is that if you actually go get a USB scale, it doesn't implement the USB weights and measurement schema
mm,
because there were too many schemas and not enough support on the operating system side. So everybody just opened a serial port and started dumping data,
yeah.
your own proprietary scheme.
It's like going to
Um,
a restaurant with a massive menu and you can't pick it. You can't figure out what to pick. So you just
yeah,
but
exactly.
they just do it
Yeah. So
themselves,
just
sort of thing. Yeah.
Yeah, they just do it their own, but,
Mm,
and we see that all over the place, joysticks, there's, they got game pads and, arcade sticks and joysticks and, wheels and flight controllers, and nobody implements any of those. Like
mm,
they just implement a generic joystick, So to me, it's a less is more, what's the core piece that you have to do to support motion,
mhm,
insist that you can't even get certified whatever, if you don't pass this basic thing
yeah.
where everything in the motion schema is filled in and generating data that looks reasonable,
Yeah.
you know.
Yeah, that
So
makes sense.
yeah.
Um, So on the peripherals front, if we're only like if we do end up in only sending data out, like I don't know that that really helps a lot with. I think it was you that pointed me to the haptics organization stuff, was it?
Yeah, yeah.
Yeah. So like there, I think from what I've read over it so far, that's more of a consuming data from inputs. And if we're only sending data out from telemetry, then they don't really encroach on each other as efforts.
I think you might. I could be wrong.
Mm,
I think you might be reading it from the wrong standpoint. I think they're
possibly.
hardware focused,
Mm,
so they're consuming data, and you're thinking, video games producing data.
yep.
For most haptics, um, it's a one-way push.
Mm,
So force feedback wheels and force feedback devices are two-way because you output a force signal and then you input a position, and it goes in a loop.
mm,
But outside of force feedback joysticks and force feedback wheels, almost all haptics are one way. So like a seatbelt tensioner
yep.
just takes in,
Yeah, yeah.
you know, what acceleration, and then it calculates how much to tighten the belts from there.
Mm,
Wind simulators, all of these other devices, and the displays, um, light up keyboards, PC case lights, all of those things. Again, it's a one-way push
just
where they,
reacting to information from the game. Yeah.
yeah, so they're getting things like status of the flags and the starter lights and whatever,
Hmm.
and then generating, but they're never pushing anything back to the PC.
Okay.
So even for us, like motion even is a one-way push. We're
Yeah.
not
Yeah.
getting back any information about the position of the platform. That's it's up to them to keep up
Mm,
with the
mm,
data we're sending them.
yep. Okay.
So, and even on a force feedback device, people have developed systems where they they show up as a regular joystick to us, and then as a side channel, they're pulling data off of our telemetry,
Mm.
generating the forces um, themselves. Based on all
Yeah.
of
So
the
it's still
the
read.
full set of,
Yeah.
yeah,
Yep.
and then and it works fine. I mean,
Mm.
it's a little delayed, but it works fine.
Yeah, but you're
Uh,
talking like milliseconds delayed, aren't you? Like,
Yeah, so in our setup, that'd be 16 to 32 milliseconds if you're
okay.
trying to go through our telemetry API, which is
Mm,
noticeable.
hmm.
It's not, um, it's right on the threshold of what humans can detect, but with force feedback device, the big problem is stability.
Yeah.
So you'd really like to be running at 1,000 hertz,
Well, I
for
think
the
that that's the
feedback.
advantage of chunking the different parts of the standard up because you can have polling rates for maximum polling rates for each of the individual types of telemetry data. And
Right.
so for something like that, your motion object you want to be able to track pretty high. And
Yeah.
I think that's the same physics most likely that would be used for a force feedback joystick or a wheel even.
Right.
And so that would just be
Well,
really small packets that can update fast. So
yeah, and if each packet had a header you could quickly look at and say, I don't need that data, and toss it aside.
mm,
That helps even more on the client side, where
hmm.
you're only parsing motion or you're only parsing display, and you don't have to drink the fire hose.
Yeah. All right. Well, um, I don't know if you've got any more that you want to talk about at the moment, but I feel like that's a good starting discussion. Um,
Yeah, that
the
was good.
I guess now the job is to get the word out. Hopefully, this video will help
Sure.
start to get some people interested. But yeah, I figure the only way to make it happen is to like do it. So that's what I
No,
did.
I agree.
Yeah.
No, it's a good idea.
And hopefully I can
I
find enough people in those other areas that have the expertise that we can pull it together. The other
I
thing that I did want to say is that I don't want this to be something that takes a year to figure out. A couple of months should be sufficient. I think if we can get the right people involved anyway, especially for the sort of the smaller required telemetry, we should be able to infer most of that from how existing motion systems work, I think. So that part should be fairly easy to ratify. And I think the sort of game type specific stuff can always be staged. Like we can do an effort to work on racing simulate or, car-based simulators. What are the telemetry points that are required for that? And then after that, move on. If we don't have enough people to work on multiple at once, anyway. So
Well, if your underlying framework is flexible, then I think it'd be easy to
that is the
augment it
overall
later.
aim. Like, I don't want it
Yeah,
to be this is all you can send. It's like these are the things that are required, and if you have
yeah,
additional information that you want to provide, this is the framework around how you achieve that. So, like, I had a concept of feedback. Feedback items, which could be, like altitude or speedometer, etc. And
right.
that's an array of objects as well. So you just populate those with the feedback items that you need, and then we have some that are required, um, and then you can add as many additional as you want. Now the thing is, we probably have to chunk those out into smaller parts of data based on types of items, perhaps, but that's
Right.
that's that's part of the figuring out what are the required feedback items that we think every implementation should have, and then we can figure out what's the best way to structure them. So,
Yeah, no, exactly.
mm.
Well, and as I think it'd be awesome if there was a standard way for everything to get sent across. But truth is, if motion platform software companies could just have a standard way of getting data and they had to parse through it and figure out what went where. Like if everybody used a totally different term for velocity
Yeah,
or even different units, it'd be okay. They still have to come up with a custom profile for each game. It's not just going to work. Um,
yeah.
but that would be miles ahead of where they're at now, which is
Well,
like they can't even do it on
the
console.
advantage of a meta plugin means that any sufficiently motivated end user would be able to plug their game in and start creating a profile, and then it comes down to the ability to share profiles really, easily. So
Yeah.
um,
So are you thinking that the game designers could output their own proprietary telemetry and then someone can make a plugin that
well,
translates
no, I
from
mean,
that
the
to
whole idea of this idea is to standardize the output, which also effectively standardizes how motion software receives the data because it has to be in the standard.
right?
Um, so anyone that supports this standard would have a much quicker turnaround of created game to having support in motion simulators. I see it. And if someone goes off and creates their own that doesn't follow the standard, then they're going to either have to, not all motion software vendors even allow
Right.
you to create your own plugin. So you're going to have to pay them to implement a plugin. Or if it's open source, someone's going to have enough motivation to want to create the plugin. Whereas if it's in the standard, then the receiving part of all of the important information for motion simulation would just be there. And so you could use the open game telemetry standard plugin within your motion software and start to create your own working profile that is essentially just a config file against that plugin or something.
Well, that makes sense.
Yeah, so I think you could still up to the motion software vendor, but you could package once there is a configuration, you could package that with a nice icon and stuff within your software, so you can just load it easily. But you know,
Yeah,
I,
that makes a lot of
from
sense.
my experience to date, and I've had motion simulators for like 3 or 4 years now, I think. Often, you want a starting point for a profile, and then you tweak it for your given motion platform anyway, because different hardware vendors, they don't all feel exactly the same when you're in them, so you still need
Yeah,
to
yeah,
tweak. So
no
um,
doubt.
yeah, so I mean, I am aiming for as much as possible an end-to-end solution for everyone involved in, the game developers, the motion software vendors. It doesn't really hit so much on the hardware vendors, but some hardware vendors create their own motion software, so it is relevant to them, and then for the consumers, so that
Right.
it
Yeah.
just gets as easy as it could be for everyone, really.
Yeah.
And
No, it's a
then
good
I
idea.
think all of the possible additional telemetry is more about So it's kind of more in the wheel of, actually, it wasn't FlyPT that I had the call with, it was SimHub. So the SimHub developer uh, basically gets telemetry out so people can create their own physical readouts and dashboards and things
Yeah.
like that. So that's, I think, the area where the massive possibility of telemetry is, where we have to allow for that ability for the developer to add whatever they want. But it's also possible. I don't really know how many people go to that level of building those readouts.
So SimHub's super popular on our
Mm,
system, and it's used in a lot of different projects.
yeah,
So they do the base shakers, they do, like I said, wind simulators. They've got lots of custom displays,
yeah.
and
So
then in general, so
so Nicholas was who he's the developer of SimHub. I
yeah,
had nearly a 2 hour call with him. He was very on board with the concept, and it was
yeah,
him. It was him that told me about the issues of UDP. And so I think it was the FlyPT developer that was pushing for Strux. I don't
yeah,
think Nicholas had any particular bias on that at this stage, and that's the way I'm trying to attack it. Is I'm not biased. I implemented in JSON initially because it made sense to me at the time, but then as soon as the UDP packet information came about, then it's not really the right choice. But it also does come down to how much data we're having in each of these components of telemetry standardization. If each of them
yeah.
is small enough as you've suggested, then maybe JSON is okay. But I think at this point already, TOML is more minimal and actually easier to read. So I would probably lean towards TOML uh, from that aspect over JSON. But it really comes down to the interpretation of that data at the other end. So
Yeah. And like I said before, that was the big problem I had with YAML is
mm.
actual developers didn't want to deal with it. But if you had a TOML interpreter written in 2 or 3 languages,
yeah, yeah.
then that doesn't matter.
Well,
It
I
doesn't
mean,
matter really what
TOML
you
is
use.
designed to be easily cast to like a hash table, so it shouldn't be hard to do in any language. I don't think so. Um,
Yeah, but I mean, the YAML, I mean, I've written a couple
be the same.
parsers, and it's
Yeah.
yeah, it's a subset of JSON. It's easy, but everybody wants to pull an off-the-shelf thing, and then
Mm-hmm.
so if you provide them with something to parse your data, it doesn't really matter what format you use.
Well, I mean,
If you don't provide them with
that's
something, they're
the
gonna complain.
when we um, um, like the implementation that we do at the motion software side would really be provide those tools, because I don't think we can, like Sim Racing Studio is closed. We can't create a plugin for them. We can just go, here's the tools to create your plugin. And
But you could provide them with a reference library.
yeah, yeah, that's what I
Yeah.
mean. So yeah,
So, yeah, closing thoughts. One, I posted a small document in your Discord
Discord.
server
Mhm.
that outlines the data that we were outputting 10 years ago. So it's a little out of date. We've never taken away data, we
Mhm.
just added to it. Um, but it gives you a good, that's pretty much the core of what you need to be interested in. New data's come along, but it's not probably not the type of data you'd be that worried about.
Yeah.
So if you want to know what we output, it's in that document. It's got some reference to examples. And then, sorry, I lost my train of thought.
It's okay.
Yeah. So, so, yeah, that's probably it. I don't remember what I was going to say.
Well, I mean, we've been, I think, about an hour now anyway. I think that's enough. I
Yeah.
know it's getting
So,
later in the day for you, so
yeah,
so yeah, thanks, David. I really appreciate the time to have
sure.
this discussion, and the fact that you jumped in and responded to my
Oh, yeah.
email, and yeah,
Yeah, I'm happy to do it.
hopefully we
Oh,
can make some progress.
I remembered I was going to say a small point.
Hmm.
So, um, we have about 1,000 programs written for our telemetry API. So telemetry can be so much more than just motion.
Yes.
Like,
Yeah.
I do think you don't need profiles for all of that, but just having any way, I think a lot of games don't do telemetry at all.
Mm.
And having a way for them to easily do telemetry of any sort would open up a whole field of uh, third-party developers. We have a whole community built around just making cool little apps that talk to
Yeah.
our game
Yeah.
for all kinds of things. And it always astounds me how great they are at developing more tools as long as we just give them the data and let
Mm.
them do it for free.
Hmm.
So
Yeah.
anyway,
So
yeah.
on that, those apps, is that stuff that needs to be running on the same network? Or again, I'm just wondering about because I
Because we're
know
a
there's also telemetry that's really going back to the developer as a help figure out how people are using your app to improve it or that sort of thing. I don't think that that's an area that it makes sense for this effort to get into. I don't know what you think about
yeah.
that, but
So this is just when I'm saying telemetry is facing
yeah,
telemetry. So
yeah,
it's either output live while the game's running or it's
mm,
being saved to disk for offline analysis.
yep,
Offline stuff probably makes most sense in a car racing game, but maybe it fits in with planes. I don't know.
mm,
But the live stuff is where we got this 1,000 or so developers and or apps, and um, yeah, I mean it astounds me. They're collecting stats on your car. They're
mm,
building tools to hook friends together. They're hooking it up to Discord. They're doing all kinds of crazy things with it, and it's pretty amazing. And then every weird little piece of hardware that we don't support, somebody's tried to write a plugin for it.
yep.
So
Well, I mean, the value there is it helps make your game more sticky, I guess. So having it be easy to give that data out
yeah,
when you have the right audience is of high value. So yeah, I agree. I think that's to me that's largely the concept of feedback items is that you could implement as much of that or as little as that as you want.
yeah,
Um, and I can think of like you said for race stuff, but for flight you could if you had GPS coordinates as a streamed thing, you could create flight logs automatically in an external app and
exactly,
stuff like that. So yeah,
exactly, yeah.
yeah, high benefit.
Well, and to me, all of this is part of building a community. That's
Mm,
my thought with all of this is you want people to be buying peripherals and developing apps and using community driven stuff,
mm,
so that they're getting more out of the game than just sitting down and
yes,
playing it. So that
100%.
they're going, wow, look at this cool new toy I get to play with.
Mm, yeah,
That's what keeps us going. Um, if we didn't, if it was just a game, if we just gave everybody a joystick and no peripherals and no telemetry and no nothing, they would get a lot more bored with the
yeah,
process
yeah.
because they can dream of motion platforms and all these other cool toys. Um, it keeps them coming back.
Mm.
So it's all about community in my mind, and that's every game could benefit from having a